This week we are going to solve square root equations. We've been talking a lot about radicals during this quarter, and now we're actually going to solve some equations using them. We're going to focus on square root equations this lesson. A square root equation is an equation that has a variable in the radicand. And as a reminder, the radicand, remember, is what is underneath the radical symbol. So in order to solve these types of equations, the first thing we have to do is isolate the radical sign on one side of the equation. Doesn't really matter which side. And then in order to remove that radical symbol, since we're dealing with square roots, we have to square both sides of the equation. And then you're going to solve for the variable just like you would with any other equation. So if you take a look at question number 1, you'll see that we have a radical. We do have a variable in the radicand, so therefore this is a square root equation. And the first thing we have to do is isolate that radical. The part that's keeping this radical from being isolated all by itself is this minus 1. So all we have to do is add 1 on both sides, so that now we've got the square root of 3x plus 3 is equal to 6. Now, this is what's considered to be isolated. There's nothing else with that radical. So step 2 says that we need to then square both sides of the equation in order to remove that square root symbol. So when we square both sides, that's simply going to get rid of our radical. When you multiply, you should remember this from geometry and the Pythagorean theorem, but when you are squaring this, it will remove that square root symbol. This gives you 3x plus 3 equals 36. And now this looks like an equation that you've solved 100 times. You're simply going to get that x by itself, so subtract 3 from both sides. 3x is equal to 33. And then you're dividing by 3. So x is going to equal 11. You can substitute that back in to see if you're right. 3 times 11 is 33. 33 plus 3 is 36. The square root of 36 is 6, and 6 minus 1 is equal to 5. Taking a look at number 2, our goal is again to isolate that radical symbol. So that means that this time we've got a couple of pieces we need to get rid of. In order to isolate that, we have to get rid of this minus 18, but we also have to get rid of the 3 because it is not part of the radicand. It's on the outside of the radical symbol. So we're going to add 18 to both sides first. Then you're going to have 3 times the square root of x. 18 plus 18 is 36. We still don't have that radical symbol isolated. We've got this 3 that we need to remove. Since that 3 is being multiplied times the square root, we'll have to divide by 3 to get rid of it. So now we've got the square root of x is equal to 12. Now we've got the square root isolated, so then we have to square both sides of the equation. So I'm going to square both sides. That's going to undo that radical to leave me just the x all by itself, and 12 to the second power, or 12 squared, is 144. So this time our variable is equal to, or x is equal to 144. Taking a look at number 3, you'll note that the absolute, or not the absolute value, the square root symbol is already isolated. There's nothing with it, nothing being added or subtracted, nothing being multiplied to it. So it's already isolated. So the only thing we have to do is square both sides. If we square both sides, that's going to lift off that radical. So now we've just have 8 minus x, and 4 squared is 16. So we need to get that x by itself. We'll subtract our 8. And now we've got negative x is equal to 16 minus 8, which is 8. Remember that that negative in front of our x is really a -1. So that means I need to divide both sides by -1. So x is equal to -8. On number 4, you can see that we've got this radical, but we have this -5 that is keeping it from being isolated. So we'll start by adding 5 to both sides. So now we have the square root of y plus 2 is equal to 9. Now that our radical is isolated, we can square both sides. And we have, when that undoes that radical sign, we've got y plus 2 is equal to 9 squared. 9 squared is 81. So now we just have to get rid of that 2 by subtracting, and our y is equal to 79. A couple more examples. If we look at number 5, you'll see it's similar to number 3 in that the radical symbol is already isolated. There's nothing in front of it or behind it. Everything is underneath it. So I can, use the wrong color, I can go ahead and square both sides of that to begin with, since I didn't have to do any work to isolate that. Squaring that's going to undo that radical symbol, giving me 2x, and 6 squared is 36, 6 times 6. Simply divide by 2, so our x is equal to 18 this time. Number 6 is a little different. You'll see I have a negative sign out in front of my radical symbol. And let's recall, that really means that's a -1 hanging out there. So that means I am going to have to get rid of that -1 as well as this +4. I'll start with the +4. I'll have to subtract that from both sides. So that gives me -1 times the square root of 25x is equal to -6 minus 4 is -10. Well, I still have to get rid of that -1. So similar to number 2, when we had that 3 out in front, we had to divide both sides by 3. I'm going to have to do the same thing on number 6, except I'm just dividing by a -1 because that's what's out front, being multiplied times that radical symbol. So when I divide by -1, that's going to give me the square root of 25x is equal to +10. Now my square root symbol is isolated, so I can square both sides to remove it. That's going to give us, let's see, what will that be? 25x equal to 10 squared is 100. Simply divide by 25. So x is equal to 4. 100 divided by 25 is 4. Last 2 examples. Hopefully we're starting to get the hang of this. Can see that the square root is not isolated. I do have this -3, so that means we're going to start by adding 3 to both sides. Square root of 8x minus 15 is equal to 3. I've successfully isolated that radical symbol, so I will now square both sides of my equation, which will give us 8x minus 15 is equal to 3 squared is 9, 3 times 3. And now I'm just going to solve this equation like I would any other. Get that variable by itself. 8x is equal to 9 plus 15 is 24. Divide both sides by 8 since that was being multiplied, so x is equal to 3. This last equation on number 8, very similar to number 7. So hopefully at this point you're saying, well, I know what to do. I need to isolate this radical symbol, so that means we'll have to start by adding 4 to both sides. So the square root of 4x minus 7 is equal to 5. And you're saying, hopefully, well, I know that I've got this isolated, so now my next step is to square both sides of this equation, which gives us 4x minus 7 equal to 25. And again, this is just a little baby two-step equation. By adding 7 to both sides, I get 4x is equal to 32. And then I have to divide by 4 to get that x is equal to 8. That's not a very good 8. See if I can make it any better. Okay, so that is examples on how to solve square root equations. Taking it back, let's recall a square root equation is simply an equation that has a variable in the radicand, which means it is underneath the square root symbol. And in order to solve, you've got to isolate that radical symbol and then square both sides of your equation. Lastly, solving for your unknown.